So this is a picture of the edge of the universe. That is a picture of the edge of the visible universe. We can't ever see farther than that. It's not possible. Why? Well, because there's no light coming from beyond that point. Why? Because the universe is expanding. Huh? Stay with me here. We've observed that every galaxy in the universe that isn't gravitationally bound to our galaxy is moving away from us, and doing so in a very uniform fashion. Without fail, we measure that the farther away that a galaxy is, the faster that it appears to be receding from us.
Okay.
And that's a peculiar observation. I mean, a relationship that reliably linear is consistent with and really only makes sense if the galaxies themselves aren't actually moving, but rather the space between them is in some sense growing.
What? I don't get it.
Well, here's an analogy. Imagine that the galaxies are like raisins in a ball of dough, which is rising as it bakes. From the perspective of any of the raisins, all of the others appear to move away from it, with greater speeds at greater distances. But see, the raisins, galaxies, aren't themselves moving. The thing that they're embedded in, the dough, space, is expanding. See, this pattern here is just what naturally arises with things in an expanding medium.
Okay, but how could space expand?
Well, it certainly isn't intuitive, but evidently, space itself is not just some static entity, but rather it is dynamic. You see, the crux of Einstein's general theory of relativity is that what we observe and experience as gravity is nothing more than the curvature of space, or more precisely, space-time. And this is an idea that's been tested and verified time and time again. Every prediction made by Einstein's theory has been vindicated over this last century. And one of those predictions is that if space on its largest scales is more or less uniformly filled with matter and